In this class, we are going to discuss about PITOT tube. So in previous class, we had a discussion on the topic U-tube manometer as well as how U-tube manometer is used for measuring pressure in orifice as well as venturi. So this class, we are going to see about PITOT tube, how the PITOT tube is going to measure flow measurement. So PITOT tube is a pressure measurement instrument. It's used to measure fluid flow velocity. And it was invented by the French engineer Henri Pitot during the year 18th century. Then it was modified in the mid of 19th by a French scientist Henri Darcy. And the main use of PITOT tube is used to determine the airspeed of an aircraft as well as water speed of a boat. And moreover, in industrial application, in any particular point, if you want to measure the flow rate, then we can go for PITOT tube. So it is used to measure the local velocity at a given point in the flow stream, not the average velocity in a pipe. So you can't able to use it for like venturi and orifice. PITOT tube cannot be useful. So the basic PITOT tube, which consists of a tube pointing directly into the fluid flow. So the path which is consisting of a single tube, that tube it is like a 90-degree horizontal line. As this tube contains a fluid, a pressure can measure. The moving fluid is brought to rest, that is called stagnant. So whatever the pressure is creating in that particular area, which is called as in stagnation pressure. And moreover, there is no outlet to allow the flow to continue. So this pressure, the stagnation pressure of the fluid, is also known as total pressure, and it is also called PITOT pressure. So the liquid flows up the tube, and when equilibrium is attained, the liquid reaches a height above the free space of the water stream. So you can able to see the diagram over here. This is what the PITOT tube construction. Here in the diagram, this is the flow path. In the flow path, if there is a blunt object, then the velocity will be 0, right? So V2 is equal to 0. So the basic principle, if a blunt object is placed in the flow channel, then the velocity of the fluid at the point will be 0. So here in this diagram, this is what your fluid path. In that you have a tube, and this tube we used to call it as a PITOT tube. So whatever the pressure created at the inlet, that is P1, and the pressure created after the PITOT tube, this is called P2. So here, according to Bernoulli's equation, rho 1 by gamma plus V1 squared by 2g, which is equal to P2 by gamma plus V2 squared by 2g. Here the Z1 and the Z2 both are cancelled because of we are using horizontal. The datum lines are going to be cancelled. And moreover, here after this particular PITOT tube, the velocity is going to be 0. That is the reason your V2 is 0. So this equation has become V1 squared by 2g, which is equal to P2 minus P1 divided by gamma. So from the above equation, if you are calculating V1, you will get root of 2g by gamma of P2 minus P1. So this is what the pressure measurement we can able to calculate it. So when you are looking at here the PITOT tube, and the PITOT tube is consisting of, this is a tube, it is a small tube and 90-degree inclined, and this is the fluid path. This is the flow path. In that you have a fluid, right? So this PITOT tube were inserted on the flow path. This PITOT tube is used for measuring a flow rate. Not only that, it is used to measure the velocity of the flow in a particular point. So while you are seeing in the diagram, the pressure at this point, that is 1 and 1 dash, the pressure is different. Then for 2 and 2 dash, the pressure is different. So whatever the pressure creating from this location to this location is called static head. Above the level, that is above the fluid path, your tube, the height from this location to this location, which is called it as a dynamic head. So when you are adding the both dynamic and the static head will give you the result of stagnation. So stagnation, which is called the pressure created in the point of stagnation head, which is called as in stagnation pressure. So stagnation pressure, which is small h plus capital H. So this point in your dynamic head, the velocity will be 0. Why? Because here the pressure different and the velocity is different. After entering the fluid inside the tube, the pressure as well as the velocity value is going to change. So this part, this location, your velocity V2 is become 0. So just look at the diagram over here. I have just divided it into 3 parts. The first part, which is nothing but the entry portion. So the fluid flow, it's going upstream towards the tube. So you have a pipeline and tube and the fluid path. Then for the second diagram, you can just look at here. After entering into upstream, already the fluid is in the up portion. It will also comes down. So there will be a force. What will happen? The velocity present in this particular point will be less. That is because of due to gravity. So here it's going to come down. And the third portion, already the fluid is coming this location, and here it is also coming from above the point. So automatically what will happen? It will get stagnant. So if it is getting stagnant, then automatically the velocity value will be 0. So both are in the equilibrium state. That is called it as in rest position. So that is what called the static equilibrium. So based on Bernoulli's expression, P1 by rho g plus V1 square by 2g plus Z1, which is equal to P2 by rho g plus V2 square by 2g plus Z2. So we all know Z1 and Z2 both are equal. So I am just going to cancel those two. So this P1, this pressure head, which is nothing but the previous diagram, you can just look at here the pressure rate, which is nothing but your static head. And the second location from this point to this point, it is going to be H plus capital H. So what will happen? This H plus V1 square by 2g, which is equal to, already it is in stagnant, so velocity V2 is equal to 0. So you will have P2 by rho g. This is pressure head. Here it is considered to be in stagnation head, and the stagnation head, which is nothing but summation of your dynamic as well as static. So you will have small h plus capital H. So this h and h term will get cancelled. So you will have P1 square by 2g is equal to small h. So above this expression, if you are calculating the velocity V1, we can able to calculate it is in terms of root of 2gh. So if there is a friction force between the fluid and the tube, generally there will be a friction force. So how to avoid that? So what we are supposed to do is we have to modify the coefficient of discharge equation. So coefficient of discharge, which will be calculated CV, which is equal to actual discharge divided by theoretical discharge. So actual means what? That is already we have obtained. So CV into root of 2gh you will have. So what is CV depends here. VA, which is nothing but actual discharge. CV is discharge coefficient. CTH, which is nothing but theoretical coefficient discharge of the flow. So here the CV is depends on the length and the diameter of the tube. So you will have the actual discharge VA, which is equal to CV into root of 2gh. So this is how we can able to calculate the actual discharge value using this PITOT tube. So what are all the limitations when you are coming across this PITOT tube? The velocity is very low, so automatically the difference in pressure is also very small. So we can't able to measure with the transducer. Point number 2. There is an error which will be present in greater amount. So PITOT tube does not work very well for very low velocities. only for the particular point you can able to measure the velocity of this particular PITOT tube. But if you are comparing with Venturi and orifice, it's not so. So the velocity is very high. We have violated the assumption of Bernoulli's equation. That is the reason they are not using. But if you are using the concept, if you are using the same thing, then there will be a shock wave appears that will change the total pressure. So we have to do some correction factor for the measurement of high speed aircraft speed. Then the tube is become clogged or pinched. That means if there is any dirty particle which was present in the flow of liquid, then automatically that will affect the static pressure which was present because of the external flow. So the transducer output then used to calculate the velocity, that is not also an actual velocity of the flow. So you couldn't able to calculate the actual velocity of the particular flow liquid, the flow of liquid. So what are the advantages of PITOT tube? The advantages, which is nothing but it presents little resistance to flow and it is inexpensive, and these type of measurement, that is PITOT tube, is used on different diameter pipes. That is, if you want to change the diameter for the pipes for different application, then it is suitable. Then disadvantages, it is like turn down is limited to approximately 4 to 1 by the square root relationship between the pressure and the velocity. And if the stream is wet, then the bottom holes can become effectively blocked. Why? Because the tube is very less and very thin. So you can't, the fluid can't enter into the PITOT tube. So it will automatically create a blockage inside the tube. And it is very sensitive to changes in the turbulence and needs careful installation and maintenance. The low pressure drop measured by the unit is also going to get increased, especially on the steam. And placement inside the pipe work is also critical, because if you can't able to place it according to the structure of the tube and the inclination and the degree, we have to place. And moreover, the PITOT tube where it is used in the industrial, how they are using means the PITOT tube which was inserted in the tube and the same tube output which is connected with a diaphragm. So what will happen if the pressure difference, because the inlet as well as where you are going to place the PITOT tube, that point the pressure is different. So those 2 points they will just insert the board on like diaphragm, and according to the flow of the liquid, the diaphragm, inside the diaphragm there will be an fluctuation. That is because it is an elastic pressure measuring device now. So automatically the diaphragm will identify the differential pressure head based on these 2 points, that is your pressure drop point as well as the stagnation pressure. So automatically it can able to measure the pressure value. So using that pressure value, we can able to calibrate it in terms of flow of liquid, in which we can able to calculate the flow rate of the liquid. That is how your PITOT tube is working. So this is what this particular video, I think you will understand. Thank you.